Starting. All attendees are in listen-only mode.
Hello, this is Adrian Jensen with Predictive Engineering. This is a technical seminar on Femap and NX Nastran, and today I just kind of want to give an overview. We have a lot of new users. There's lots of tips and tricks in here that'll be useful for experienced users, and we want to introduce some of the new features that are coming out, and also announce that Femap version 11.1.2 and Nastran version 9.1 are due to release any day now. Might be coming out this week or possibly next week. If you guys haven't done one of these webinars before, feel free to enter any questions. GoToWebinar has a questions section on the little software bar that you see there. Also, there's a chat bar. I'm flying solo today, so you guys got to help me out. If there's any problems with the audio, if you can't see my screen, any of that, go ahead and punch it into the chat bar there. I can see that. I can adjust things accordingly. Like I said, it's just me. George might join us. If I don't have time to answer your questions during the webinar, I'll follow up afterwards and get back to you via email. And if you don't mind, you can go ahead and send a little test message into the chat letting me know that you can all hear me, that the software is cooperating, my headset's working. But all right, so today I want to start with basically a brand new install for Femap. So this is what we'd see with a fresh installation. There we go. All is working, so we're good to go. All right, so this is what you see with a brand new install of Femap and NX Nastran. Everything is default. I've removed all of my custom settings, all of my special views. All of this is fresh. So for a new user or a new install on a machine for a current user, this is what you see. You get some tips of the day. If you want to get rid of these, you click this here, and this is what we've got. Now, if you check out the attachment that came out with the webinar notification, you'll see there's a couple different things that we categorize under Welcome to Femap. We've got panes, we've got toolbars, and we've got the preferences. So I want to spend about 15-20 minutes just to walk through each of these things, because a lot of times when you're running into problems down the road, coming back and working with preferences here could be the solution to your problem. All right, so first of all, let's talk about the organization of the graphic interface. Like a lot of Windows programs, it uses toolbars and it uses panes. So these window panes, you can move them around. I'm just grabbing the top here, clicking it and dragging it. You can resize it. You can close them. You can put them wherever you want. A lot of times if you have dual monitors, you can remove all this stuff, put it on the other monitor, and then you're going to have all of this space just for your model here. Thanks, John. If you close these and you're wondering how to get them back, come up to the Tools menu bar, and you see these are all of your window panes here. So if we go to Other Windows, there's that Messages bar. The other thing you see as you move these around is these little locators pop up. It's like a little diamond here, and they're also on the side. And that just shows you how to snap that window pane into a certain location. So I like to snap the message window on the bottom here. The model info tree is another really important window pane. It's really useful as you're working through the modeling process. You have that here. And the other one that I like is entity info. And it's just a little one here. When we're working with curves, surfaces, mesh, whatever, this will give us information about the active entity we have. Let's bring in some geometry just so we have something to work with here. And this is just a little example model that we've been working on. The other thing we've got to work with as far as the interface goes is toolbars. And these are located across the top by default, and these are the default toolbars. Similar thing, just like with Microsoft Office products, you can move these toolbars around, you can close them, you can actually park them a lot of different places in the Femap interface. And if you close these or want to add new toolbars, you come to Tools, Toolbars, and here's a list of all these different toolbars here. You can get to the same list by right-clicking in the space up here, and you can see you can turn on and turn off these toolbars. In some of our other online seminars, we talk about automation and customization, so you can come in and customize your toolbars. Say there's certain commands that you're using on a daily basis and you hate searching through the file menus to find those. We can add those commands right here. Let's say we want to rebuild our model file before we save it to help compact the model size. I'm just going to click and drag that button, put it right there next to save. That way I don't have to hunt through the file menus. So there's lots of different things you can do. You can create new toolbars with all of your own custom commands. You can do simple modifications like I just did there. And you can really get everything set up just the way you like. Now once you have all of this stuff organized the way you like, and you have a new installation or you switch computers, you have to go through this whole process again. Well, fortunately there's a way to avoid that. You can actually save this layout, is what they call it, is a layout file, and that remembers your window panes, your locations, your sizes, your toolbars, your custom commands. It remembers all of that for you, and that's located within Preferences. So let's go to File, Preferences, not to be confused with References. So come to Preferences, and let's just walk through these one by one. There's lots of different tabs here. And there's lots of important stuff here. So I'm just going to work my way through. Messages, generally I leave the defaults with messages, and this relates to the messages window here. So having your message window pane open is very important. Lots of good information gets dumped there during the process, but the defaults are going to take care of here. You're going to get plenty of messages. Views, now this is where it gets a little bit more fun. If you want to take screenshots of your model, you can control the resolution of your screenshots. So by default, it'll use your screen resolution. If you want really high resolution images, I recommend this option here, screen scaled by. I use something like a 4x, and that is plenty big. We recently went to the Femap symposium. We had a huge banner, maybe 4 feet tall, 6 feet wide. I used a screenshot right out of Femap, and even blown up that big, it still looked great. So this is a really handy little thing. If you're working with engineering reports or need graphics for something online, emails, any of that, it's a great way to get high quality images. Okay, and we could even let's do a little test run here. I'm going to drop these to PowerPoint. So let's do a screenshot with just the default resolution here. And I'll say File, Picture, Copy. And let's just drop that in a PowerPoint here. So there we go. It's not bad. If we zoom in, it's a little grainy here. If we up that resolution, let's say screen scaled by 4, we'll do that same screenshot, picture, copy. Look at that, much, much larger. So you get a great high quality image there. All right, moving on, back in Preferences. The other thing in Views is your startup view. So we talked about customizing toolbars and panes, but you can also customize your view, your background color, the color of your text size, your font. All of this stuff is going to be customizable within Femap. And say you get everything set up just the way you like, you save that view, you can use that customized view for all of your new models. We have a model on the Predictive Engineering website with our preferred view settings. So if you like what you see, you can download that model, save that view to your library, and you can use that as your default. So you see here, I have one here called Predictive Engineering. That's my default view. So any new models that I start up are going to use my default view, and I don't have to go through and change all the colors and sizes and everything there. Okay. Graphics. Now, graphics controls not really your resolution for your screenshots, but what we control here is what gets displayed on screen during the modeling process. There's a couple of different things here that I like to mess with, especially with really complicated or large models. That's the dynamic rotation. You can choose what gets included in dynamic rotation. So right now, pretty much everything gets included. But if I wanted to turn off a few of these things like points and curves, now those points and curves turn off when I'm rotating the model. And that just is a little bit more economical as far as your graphics are concerned for big models. User interface. This is where you get to save and load your layouts. So I was talking about once you get everything just the way you like here, come into preferences and save your layout. I'm going to just do, we can call this one a test layout. That way when I move to a new computer or I have a new version of Femap installed on my machine, I can come into preferences, load my layout, and it'll update everything just the way I had it before. It's somewhat compatible between versions, so that's really useful. The other thing we'll see here, auto repeat commands. We'll see this once we start to get into the workflow. When you say you need to create 10 different materials, auto repeat will automatically kind of prompt, all right, here's your first one, you want to make another one. And it'll bring up the auto repeat when we see it in the modeling process. Database. Now, this is really important, your scratch directory. During the modeling and analysis process, Femap is constantly generating these temporary files. Femap generates temporary files so you can do things like undo, or maybe it's going to crash during a save. It'll help you recover those files that crashed. You want all these temporary files directed to one location, and by default, Femap will set up a scratch drive for you. You can see mine's just on the C drive here. So if all these temporary files end up in one location and I know where that is, I can clean them out once a month and I don't have to go hunting through all the different directories. The other important thing is you want this on your local drive. You don't want to be writing scratch files across your network. That can really slow things down. So be aware of that. Geometry, model file, I go with the default settings here. Interfaces, this is where this scratch directory comes up again. So the previous one lets us know where Femap is going to be creating its temporary files. The scratch we see here on the Interfaces tab is where Nastran is going to be generating its temporary files. So the two settings I say is pick an output directory, option 2, direct output to, again, option 2, a specified directory, and pick that same folder on your local C drive. Again, we don't want to write this stuff over the network. A few other things that are important on this page, if you're working with a large model, you can choose to use the 64-bit Nastran. This isn't something that you want on all the time. This is something you kind of want to use when necessary. If you're using it all the time, you're kind of requesting more resources from your computer than you really need. So if you're solving a really large model, use this option here. Results, I would say if you're working with very, very large result sets, gigabytes of data, you want to go ahead and look into attaching to results files. And when we had our version 11 release webinar, we had an example of attaching to results files. There's lots of kind of different techniques there. So if that's something that interests you, check out our website because we have a bit more in-depth information on that one. Our libraries, all this is going to be our default here. Colors, this is just the default colors for curves, points, surfaces, etc. And if you use a spaceball or a 3D mouse, you can do a little bit of adjusting here. So that pretty much covers it for the preferences. This is always good to walk through with a new install or for a new user, kind of take this step by step. Now, I'm going to do one quick thing here. Let's go ahead and load a view. The view that I have a couple of views saved here, and I'm going to get to them from visibility. Visibility is what turns on and off all of the different entities within our view. You can see I can turn off points, curves, surfaces. I can also load and save views. So when I get everything set just right, I can load a view. You can see I've got a predictive engineering view here. And my backgrounds are different. My curve colors are different. And those views are what I set as default within the preferences. So that's really pretty useful. All right, so at this stage, I kind of want to get started with our analysis workflow. It's about 8:45. I want to have plenty of time for this, and hopefully time for a few questions at the end. And so let's work through this. The first step in our analysis workflow, if we look here, is geometry. Now, there's always going to be different ways of doing any of these steps within the analysis workflow within Femap. They give you lots of options, toolbars, file menus, the selector, plenty of different ways to do it. But the general workflow is always going to be the same sequence. Today, I want to work from the file menus up here. It's kind of the classic way to do it. I could do the same from the info tree or the selector. And again, we have webinars to cover those in a bit more in depth. But this is the process I want to follow here. All right, so first, geometry. I imported my geometry here. That was File, Import, Geometry. Femap will support a wide range of geometry files. If I'm working with something simple, I'll generate my geometry within Femap. And today what I want to do is I'm going to mesh this upper and lower machine part, and then I want to mesh these tubes here with beam elements. So I'm going to need to create some curves there to create my beam element mesh. Other thing I always do with a new set of geometry, pardon the train, we're right next to the train tracks. Something I do with a new set of geometry is make sure that I've imported it with the right scale factor. So let's go ahead and measure this and make sure that I'm in the right unit system. Right here is the measure tool. You can see there's distance. Say I wanted to measure between 2 points. I would right-click, snap to point. I can measure from here down to here. There we go. So it tells me that's about 9 inches or 9 millimeters. Whatever unit system you're working in, that'll give you a good idea that the import scale factor was correct. A new feature they've added is distance between geometry. So I could say, all right, just give me the minimum distance between 2 solids. And I pick this solid. You can see the top here, measure from. And we're going to measure 2. There we go. So that's a new tool. If you're not exactly sure what 2 points you want to measure from, you just want to get a general distance between bodies, that's really handy there. All right, so I need to get some of this stuff out of the way, out of the view. And from the model info tree, I could blank these one by one and hide them from my view. But something that I think is a lot more useful is using the selector. So I'm going to use the select tool here, and it looks just like this. I'll go ahead and drag it down so it's a bit more visible. I'm going to switch to solids, and I'm going to switch my mode to select multiple. This way I can turn on and off multiple solids. So you can see with this selector on, as I hover over solids, they kind of have a highlight to them. So I could click these here, and it puts a little marker on the CG of those solids. Now when I right click, I have all these options. I could delete them, I could group them, mesh them. What I like here is the visibility options. So I can show selected only, go back through, show all, hide selected. So I think this is much, much quicker than hunting through the model info tree, trying to find the solid you want and turning it on and off with the checkboxes here. So again, this is the selector toolbar. Another little shortcut here, I'm sure you can find this in the Femap help files, is if you want to jump straight to this visibility menu, you can hold the shift key. So hold shift, right click, and you can see it jumps straight to that visibility menu. So I'm going to do show all, show selected only, and I'd accidentally pick that. What happens with the selector here is you've got a selection list. So if you need to clear that and start over, that button clears the list. So I just want these two tubes right now. Now I'm going to say show selected only. There we go. Now I can clear this, turn it off, park it over to the side, because we're going to create some curves here and mesh beams on those curves later on. So I'm going to say geometry, curve, coordinates. This is kind of my general go-to command for creating straight lines in 3D space. And I want this curve to run down the center line of this tube here. So I could snap to one of the points on the edge here, but I don't really have a point right in the middle to snap to. That's where methods comes in really handy. Methods, I want to use the center method. So it's going to look for circular curves like this here. When I pick that circular curve, it'll find the center of that circle and use those coordinates for my curve. Now I've got to pick the other end of the curve, which is going to be down here. Okay, and if I look down in this tube here, I now have a curve running down the center. You can see that there. All right, let's do the same thing for this tube. I'm going to go from here, okay, to here, okay. So now I have curves. Let's turn all of our geometry back on. So I'm using the selector, show all, and I'm going to hide these tubes here. There we go. I'm going to go ahead and break these curves because I want to put some constraints at these sliders here. So I'm going to say modify, break. And I want to break this curve and this curve. This is the entity selection dialog box, and you guys are going to see this for everything within Femap. Anytime you're picking any sort of entities off the screen, this is the little box they let you use to keep things organized. I like the highlighter here to preview what I've selected. All right, now I've got to pick where to break these curves. It's one long continuous curve. I want to break them at the center of these little collars. So the method I want to use this time is midpoint. I'm going to pick the midpoint of this curve, click OK. So it has broken those curves, and you can see as I highlight now, these are now the upper and lower portions are now separate curves. So let's do the same thing for the lower collar right here. Okay, so now when I highlight, I've now broken those 2 long curves into 6 shorter curves. So that pretty much covers all of the geometry work I need to do. If we go back and look at our little walkthrough here, first we've got geometry. Next is materials and properties. This is pretty straightforward in this model. I'm going to say model, material. We're going to load a material from the Femap material library. Now this is the default library. If you want to change your libraries, find your Femap directory, and you can see material, engineering, And there's the inch, pound, PSI unit system. Here's a millimeter, Newton, ton unit system. So they give you some material libraries. If you wanted to modify one of these here, let's say we're just going to say we'll change the modulus. I could save this material here, and it'll save to whatever active material library I want. If you want to create your own material library with all of your own custom materials, that is definitely a possibility. You can always reference these back in the Preferences tab. Something else I like to say with materials is I like to remove any sort of information about the material that I don't need. It's just extra information. If you end up doing some sort of thermal analysis down the road, you're going to have to force yourself to check these units, make sure everything is correct here. So I'm going to call this generic aluminum, and all I really need for my static analysis is a stiffness and a Poisson's ratio. So I'm going to delete everything else out of here. There we go. There's my generic aluminum. And I only need one material, so I'm good to go. If you want to follow along with what you've been creating, this is where the model info tree is really useful, because you can see here it shows me the material I've just generated. Let's create some properties. So there's going to be two properties. I want to use a solid mesh for these machine parts and a beam mesh for these curves. So let's do the solid first. Here is my element type, solid. I'll pick my material. I can give it a name. And if I want, I could give it a color. That's about all I need to do. Now, for the beams, it's a bit trickier. Let's switch our property type to beam. And you can see I have a lot more information to fill out here. Femap will help you out, though, because we can just pick a shape for our beam. Those are circular tubes. We can give it a radius and a thickness. Get a little preview there of our cross-section, and it calculates all of our section properties for us. So let's give this a name. Again, if you want, you can pick a color. There we go. So when I click OK here, you can see it automatically pops back up. That's that auto-generate command I was talking about within Preferences. So if you like that, it's useful. If you don't like it, you can always turn it off. When you get to the point where you've made all the properties you want, you just click Cancel, and you'll see that property 1 and 2 have been generated. All right, that's materials and properties. Next is our mesh sizing. So let's do our curves first, and I'm going to hide all of the solid bodies using the selector. Hide all. Now these curves don't go away because they're not part of a solid body. They're free-floating curves. So just be aware that that's why they're not disappearing when I said hide all. Let's use mesh, mesh control, size along curve. You want to use the appropriate mesh sizing command that's going to match the element type you're using. So we're meshing curves. We're going to mesh them with beam elements. I'm going to use size along curve. I'll pick these here. I can preview. And there we go. Number of elements. Each curve, I'm going to give it 4 elements. That'll give me some good resolution in the deformed plot at the end. Now it's a little hard to see on my screen here, but there's going to be little dots along the curve, and that's where your nodes are going to be placed. So it gives you a preview of the mesh size. Okay, next is our mesh size for our solid bodies. So I'll show all, and the only 2 I really want to mesh are these 2 here. There we go. So to do this, there's a couple of different options. I could say mesh, control, size on solid, But the command we like to use when we're going to be working with a tetrahedral mesh on complicated geometry like this is geometry preparation. So let's use this command, and I'll pick these two solids. I'm going to use a little bit bigger element size here. I want 0.1. And this is going to prepare the geometry. It's going to find slivers, it's going to find small curves, adjacent points, and it's going to help merge this stuff together. It's using a lot of different commands that are available in the meshing toolbox, which we'll touch on here in a second, to prepare the geometry for the best possible mesh quality. So we click OK. This command takes a little bit longer. And if you look, some of the surfaces have turned green. Some of the curves have changed colors. Those are the surfaces and curves that this command has modified for us. So there we go. Let's put a mesh on these, and then we can see what sort of element quality we have. So mesh, geometry, solids. We're not going to hex mesh. We're going to use a tetrahedral mesh. So I'll put this one and this one. I'll select my machined parts property, and we'll click OK. Okay, so how do I actually tell if I have a good element quality or not? I can kind of look at it and see, most of these are pretty regular triangles, but, there's so many of them. I've got 80,000 elements. So the tools that we use to help identify bad elements is this model data contour command. And if you don't have it on a toolbar here, you can go to View, Advanced Post, and there it is. To help clean up my view a bit, I want to get rid of these surfaces, these curves, all this stuff, get it out of the way. I'm going to go back to Visibility. So that was a command I showed earlier here, View Visibility or View Visibility. I'm going to turn everything off except my elements. Makes for a little cleaner view. Now we'll use this model data contour command. And this is a really useful tool. There's lots of different applications here. You can contour all different types of information on your model. So I recommend kind of digging in and looking through the different options here. But what we want is to contour the element Jacobian. That is a good indicator of element quality. And we're going to turn on Allow Labels, so it'll actually label our highest Jacobian, which will be our worst. And there it is there. So you can see this contour scale, lowest being the best quality elements and highest being the worst. So we can kind of rotate around. And there's that train again. See that small sliver there? Let's turn on our curves. And I'm going to go ahead and try and fix this nasty little area right here. And I'm doing that with the meshing toolbox. So it's a window pane here. And say we just want to try and merge together some of these nasty little curves. So I'm going to say Combine Curves. And I turn it on. And let's try this one here. Now, when I do this command, it's actually going to remesh this solid here. You can see I've got a different Jacobian, a different mesh. And the other important thing is what happens in the message window, because it'll tell you, okay, you've got an indicator of element quality. So that particular command didn't make it better. I'm going to use Control-Z to undo, and we could try something else. Maybe we're going to pick this point here and try and merge these together. Now be aware that since it is remeshing the whole solid, for more complicated solids, it's going to take a while. All right, so it's remeshed. I've gotten rid of that problem area. I've got another one over here. And obviously for a real project, you can chase these all day. We'll just do a few examples. So combining curves is really useful. The other command I find really useful is mesh sizing. So let's say we just need to add another element here. We're going to increase that element size by 1. There we go. We've added an element. It's remeshed. And look, our mesh quality has improved again. So I'm going to say it again. We have entire seminars dedicated just to working with element quality in the meshing toolbox. If this is something you're struggling with, please check them out. Please email me, and we can give you some good guidance here. Okay, let's turn this contour off. We'll mesh our beam elements now. I'm going to turn off the meshing toolbox as well. So let's say mesh geometry curve. And I'm going to pick my curves here. I'm going to pick my tube property. And I'm going to give it an orientation. Your beam element orientation cannot be along the axis of the beam. So I'm using the global X direction. That's perpendicular. That'll work just fine. Okay, so you can see this thin red line here. My beam elements have been created. If you want to preview the cross-section, this view style cube is really useful. So this is on the view toolbar. I highly recommend using this thing because you do the little drop-down menu. You've got all sorts of good options here. You can turn off your mesh sizing, those little dots, if you find them annoying. You can turn on your thickness. You can turn on shading, filled edges. All this stuff is really useful. Okay, so it looks like that is just about right. So now I need to connect them to my solid mesh. So let's say we'll turn off my thickness. That might make things a little bit easier. And we're going to create these rigid elements, these multi-point constraints. And they're going to connect my beam element to my solid elements. Model element. And I'm going to switch type to rigid. Here we go, RBE2. Now my independent node, or my central node, is going to be sitting at the end of the beam here, so I can pick that right there. My dependent nodes are going to be all the nodes on this solid mesh. Now you could go in and turn off these degrees of freedom, and you would probably ask, all right, which ones do I turn off? Why do I turn those off? Again, check out our seminars. We've got one dedicated to multi-point constraints. These things can be massive time savers, and they can also sabotage your model. So it's really good to read up on them and know what's going on before you start using them. All right, let's pick our dependent nodes. And I'm going to pick on surface. There we go. Rather than picking them one by one, I say I want all the nodes on that surface there. There we go. So it's a white element on a white background. It's a bit hard to see, but it's this little spider web here. And that's why sometimes they call them rigid spiders. So let's do the same for our other 3 connections. Sometimes if you have trouble picking a surface here, you can see I can't quite pick that surface. You can switch modes. You can right-click, pick front. So that's picking what's directly in front of the mouse. So that's pretty useful. There we go. There's another one. Let's make our last few up here. If you don't want the white elements on white background, you can always choose the color here. Let's say we want dark elements, thick lines, something like that. All right, I'm going to say on surface, here and here. You don't have to hit preview every time. I just think it's kind of useful. Here we go. You can see that one's got my new color. And last one, zoom in, grab that, pick nodes on surfaces, and there we go. All right, so I need one more, and I need one more to apply my load. So let's go ahead, back to our selector, turn on all our solids, and show everything. I want to use this solid and this solid. I'm I'm going to show just those two because I'm not going to model this solid, but that's where my load gets applied. So I need this solid out here because there's a little point out here where I want to apply my load. And then I need this solid because that's where it connects in. So let's make one more rigid element. Model, element. Our nodes will be on surface, and I'm going to grab the inside surfaces of these holes here. There we go. I could probably pick a few more if I wanted to. There we go, preview. That's why that preview button is so useful. Okay. Now my independent node, I don't have anything to pick on out here, so I'm just going to leave it blank or leave it at 0. And when I click OK, Femap will automatically prompt me, say, hey, this doesn't exist. Do we want to create it? Yes. So now I get to pick where to create this new node. It remembers my midpoint picking option from last time, so I'm going to switch back to locate. That's our default. And there's going to be a geometric point here on this solid. So I want to say snap to point. So I pick right there, I click OK, and it has created my element. So it created a new node for me and created that element. So now I have a highly idealized little lever arm here to pull on. Okay, looking through our analysis workflow, geometry, material, property, mesh size, meshing. Now we just need boundary conditions, then we can analyze. Boundary conditions for this are going to be pretty simple. I'm going to do a load nodal. I'm going to pick this node here that we just created, and we're going to pull on it in the X direction. Let's say we'll pull on it with 100 units of force. All right, now let's do the same thing for our constraints. Model, constraint, nodal. What I want to do with these is I want to pick the nodes along my beams here where I went ahead and broke those curves. So that's why I broke the curves in the first place, so I would have nodes right where I wanted them for my constraint. We'll just say those are pinned constraints. If you want to see your nodes and constraints and they're not showing up on screen, come back to visibility, and you can realize we don't see them because they're not turned on. So we can turn on everything, maybe selectively remove things from the view here. There we go. So there's my constraints, there's my load. We are ready to analyze. Now, for the analysis, there's only one thing that I want to change, only one modification, and it's on the very last page. So you have to walk through all these pages here for the analysis options, and you come here. And I want to request force balance. And I'm requesting this information so that I can generate a free body diagram. And we're going to analyze. You guys can all hear the wonderful things going on outside my window. We have trains and traffic, cars honking, so I apologize for that. Maybe my microphone won't pick up on too much of it. So post-processing all happens in the post-processing toolbox. And most commonly you see deformations and some sort of stress contours. What I want to focus on today is a free body diagram. It's a bit more advanced technique for post-processing your model. And what we're going to look at here is we're going to put a free body diagram right through this section here. Say we want to know how much shear is going through this thin section of this machined part. Maybe we need to beef it up, and we want that information for the next design iteration. That's where a free body diagram comes in really useful. All right, so this analysis runs in about a minute on my machine. We have results. You can see all these options here on the post-processing toolbox light up. We can say deform, we can say contour, and there you go. There's your standard stuff. We're looking at translation. If you want to change any of these options, you can change them here. Say we want to look at something like von Mises stress. There you go. But like I said, I'm interested in the free body diagram. So let's clear out some space here so we can actually read the options. Free body. I want to create a new free body. And I want to use my free body elements. I'm not putting a free body diagram at my constraints or at my loads or at a multi-point reaction or multi-point constraint, aka rigid element. I want to do a section cut right in the middle, so that's what I'm going to use. Now, free body diagrams can be complicated, and this is kind of my recipe for the simple starting point. You're going to do an interface load, and you're going to turn off your nodal forces. So the only vector we're going to display is a total force vector. It's going to sum forces on all of the nodes through our section cut and give us one vector to tell us what's going on. So come back to this. This is kind of your standard basic free body here. All right, so we have created the free body. Now we have to tell it where we want to create it. So let's line up our view here. We can get a good head-on shot. This button here allows me to select my elements. And I'm just going to select kind of a random slice through the middle here. Kind of remember where this is. If you want to preview what you've selected, there's a highlighter. So now my nodes, I just want to pick all of the nodes on one side of that section cut. I've got a little overlap here, but that's okay. You don't have to be perfect. It'll sort out, nodes along that interface, along that element selection. And it's going to ask me if it wants to put my vector right at the center of those nodes. And I will say yes. Okay, there we go. It's a little hidden behind some of the mesh. If I wanted to make it bigger, I could turn up my total force vector. Let's say scale factor of 5. There we go. Now it's big. Again, you could hide elements from here if you wanted to. All right, so this makes a lot of sense. We're pulling on this lever arm. It's going into bending. That bending is resolved into shear across this cut plane here. So the biggest force component of these vectors here is this shear vector. So free body is really useful. Every model I work on is going to have free body somewhere to check my loads, check my constraints, do some simple calcs. If you're working with a loads model and a stress model, you can, generate your loads model, generate free body diagrams, transfer those over to your stress models later on. It's a really, really useful tool. Okay, so I've got about 10 minutes left. Let me take a quick look at some of these questions here, and then I'll kind of wrap up with my presentation and see what we have left. All right, so we've got audio. That's good. You guys can hear the train in the background. Can we add a new material to the Femap library? Yes, we can. I think I kind of showed that here. Model, material. Let's call this custom material. There we go, 0.3. And I'm going to save this. Okay. And next go around, say we're going to create a material. Let's load a material. Scroll down to the bottom of the list and look, there's my custom material. So you can create all the custom materials you want. Can we get the symposium presentations? Yes, I think those are public domain. I'll go ahead and look into it. It's probably something we can post on our website. There's not video recordings of the presentations, but there is the PowerPoint presentations, all of their slides which could be pretty useful. So I'll go ahead and look into that, and if that's possible, then maybe we'll post them up online. And somebody mentioned the scale factor from your geometry. There's all sorts of different options there for scale factor, and that's kind of a call you're going to have to make on your own, whether you're scaling into what unit system, what level of accuracy you need. And Mike just chimed in, can you delete? Let's see, I think we can delete. Yeah, there's a delete button here. So let's see, we'll get rid of this. There we go. You could also go into this text file. These material libraries are all stashed in the Femap install. So if we came to, let's see here, material library, here we go. Here's the text format. So if you really want to dig in and modify things or change things, you can always track them down in here and locate them. Okay, so we're about out of time. My presentation, my little PDF here, gives kind of an overview of a lot of these things. A lot of this information is pulled from the Femap help files. I've been using Femap for almost 6 years. I still use the Femap help files. They're incredibly useful. There's tons of information there. So here's a good overview, but always kind of reference the help files. And then, throughout this entire presentation, I kept saying, oh, we have more, we have more. So check out the Predictive Engineering website. If you come to the Resources tab, you'll see all of our old webinars are on here. We record them. This one will probably be up in a week, maybe 2 weeks, and I'll include this presentation and some example files. So if there's more topics that you want to do some self-training on, check out the website. It's going to be really useful here. Fatigue Essentials. This is a new program we've been working on. If you're doing fatigue analysis, you can also find that here. We've got the web link within the document. And if you guys want to go in for some serious Femap and NX Nastran training, we offer classes, both for NX Nastran and for LS-DYNA. So this is some tentative dates when we're trying to set up our next classes. It's a week-long, intensive, all day, but you have an opportunity to learn a ton. All right, so that pretty much wraps it up. Again, I'll follow up with more questions via email. You guys have my contact info. Feel free to email me. And yeah, we'll put this online as soon as we can. Thank you all for attending. All right, have a nice day.